Trying to get the
Hello everybody, welcome to tonight's webinar, which is all about going all electric at home and transitioning from gas. We'll get started at about, right on the dot of 7 o'clock, which is only a few minutes away. So sit tight and we'll be with you soon. Good evening, everybody. My name is Sam. I'm the Climate Emergency Coordinator at the City of Yarra. Thanks for coming along tonight and welcome to tonight's webinar, which is really mostly a Q&A session, which follows on from a webinar we did 3 weeks ago, which was all about the all-electric homes and transitioning from gas, essentially the why, how and when of getting off gas at home. So welcome. We'd like to begin with acknowledging the Wurundjeri Woiwurrung people as the traditional owners and true sovereigns of the land from which I'm broadcasting and perhaps from which in which you're living as well. We'd also like to acknowledge the significant contributions made by other Aboriginal and Torres Strait Islander people, and we pay our respects to elders from all nations and their elders, past, present and future. So as I said, tonight's webinar is a follow-up to a session we ran a few weeks ago, and that session was called All Electric Homes, the why, how and when of getting off gas at home. Some of you may have attended that session, and if not, it's available on the Yarra City Council website, and later tonight we'll pop that link in the chat. But tonight, as I said, tonight's session is really a Q&A session following on from that. And that session was presented as part of a 3-part series, which focused on why a renewables-led recovery is best suited to addressing the climate emergency and creating long-term growth and increasing positive health outcomes. Yarra Council, in our recently adopted climate emergency plan, has also committed to transitioning from fossil fuels, transitioning our organisation and our community from fossil fuels, including gas, to renewable energy. Some of the commitments that we've made in the climate emergency plan include moving all of Council's operations to 100% renewable, as I said, with our current focus being on transitioning our council buildings from gas to fossil fuels, from gas to renewable energy by 2030. We're working towards having all new developments in Yarra being all electric too, by introducing zero carbon standards for new commercial and residential developments, so that buildings will need to be powered by 100% renewable energy and offset residual carbon emissions. And we've got a 100% renewable Yarra campaign, which is designed to assist residents and businesses to switch to renewable energy in order to move the municipality towards a 100% renewable energy by 2030. But so there's heaps for all of us to do. There's a role for each of us in transitioning from fossil fuels, including gas, to renewable energy. And as I mentioned earlier, this webinar is solely focused on what you can do at home. It's all about answering your questions about the why, how, and when of getting off gas. So we have two people here to answer your questions tonight, two experts in the field. I'd like to introduce Damien Moyse. Damien is the Policy and Research Manager at Renew, and he, like Andrew, who I'll introduce in a minute, regularly advises on energy-related topics, including presenting at webinars for Yarra Council on buying 100% renewable energy. Andrew is an energy analyst at Renew. He's got an engineering degree, and just like Damien, he gives householders lots of advice on energy-related topics. Andrew has previously worked at the Australian Energy Market Operator, and he's also completed solar installation training, and has hands-on experience with small grid solar solutions. So it's Damien and Andrew to answer your questions tonight. With that, I will hand over to Andrew to get the night underway. Thanks, Andrew.
Thank you, Sam. So thanks for coming, everybody. I hope you can all hear me and see me okay. If not, then please just put a note in the chat or the Q&A, and we'll get that sorted out. I'll share the slides that I've got. Let me just get the sharing happening.
While you're getting your sharing happening, Andrew, one of the things I forgot to mention to people is just how we'll use our functions tonight. So if you, or when you have questions for Andrew or Damien, please pop those in the Q&A function that you can see at the bottom of your screen. If you've got really interesting links or other information or exciting tidbits to share with fellow participants, you can put those in the chat function. But any questions for the presenters, please put in the Q&A function. And we'll have a red hot crack at getting to all of those questions tonight. We may not, but yeah, we'll have a really, really good go at it. Please keep your microphones on mute so we can cut out any background noise. And we're keeping cameras off because we're recording the session. But yeah, I think that's it. Just remember Q&A function for questions. And again, Andrew, over to you. Thank you.
Thank you. So I'll start off with a quick recap of a few slides from the previous presentation. I'll be whipping through these pretty fast. I won't be explaining them in as much detail as the previous presentation, but the video of that is available. So if you're looking for more explanation on these slides, then you can find that. I think we'll have links available. So appliances, we're talking about heating, cooking, and hot water. I've got three columns on this slide, 1960, 1990, and now, 2020. And at the top is cooking. So back in the old days, people were using resistive electric cooking. That was the state of the art. Then in the 90s was gas, and now the most efficient way to cook is with an induction cooktop. The second row is hot water. So again, gone from inefficient electric to gas to efficient electric, which is a heat pump hot water system. And for heating, a similar story. Efficient electric appliances are now more economic than gas ones. They cost a bit more upfront to purchase, but you get a payback. So that may not take you too long to recoup that extra cost in lower bills. So here's an example for the annual bill saving that you might get just for heating with a reverse cycle air conditioner rather than a gas heater. So we're looking in the orders of a couple of $100 to several $100 a year savings. From an environmental point of view, efficient electric appliances are better as well. The orange is the emissions from the efficient electric appliance for an all-electric home, and the blue one is from gas. So you can see that there's almost always lower emissions if you go all-electric with efficient appliances. Okay, so how would you select an appliance? For hot water, looking at heat pumps, it's good to avoid the cheap brands and basically look for a high coefficient of performance, which is like the efficiency level. So coefficient of performance of, say, 4 or 5, it translates to an efficiency of 400 or 500%. So that's one of the best ways to find a good heat pump hot water system. With split system reverse cycle air conditioners, from an efficiency point of view, the split systems, like you can see on the left there, with an indoor unit and an outdoor unit, they're more efficient than a ducted system, which has duct of air going through the ceiling or under the floor. Look for a high star rating. You can also look at the coefficient of performance or the energy efficiency ratio, but that's included in the star rating for these units. So it's probably the simplest way for a consumer to find a good one. And induction cooktops have a lot of advantages. Probably the best way is to try it out in a store if possible, or at a friend's house, family house. Check reviews, and you just be aware that your pots are only going to work on an induction stove if a fridge magnet will stick to them. Okay, so what do? Well, an immediate thing that you can do is try heating with your existing split system reverse cycle air conditioner. Just see if it's got a heating button on it, basically, and start using it, and see what happens to your gas bill and your electricity bill. Apart from that, most people would wait until their old gas appliance wears out or needs replacing for one reason or another. That's a good way to sort of gradually work towards a long-term goal of getting off gas is just to get off those old gas appliances as they need replacing and go for an efficient electric alternative. The exception there is with the cooktop. If that's your last gas appliance, then even if it's still got some life in it, then it's actually economic to get rid of it straight away, because the cooktops don't use a lot of gas, and if you can get off gas totally, then there's big bill savings in that, avoiding that daily supply charge to have the gas connected. So that's just a brief sort of taster or reminder of what I went through in the previous session. I think we're on to the Q&A session now.
Yeah, we are, and we've already got a few questions coming in. So the first question is from Drosera Sanju, and he asks, what type of business or tradie does he need to contact to have draft proofing done, and what sort of price range would be reasonable versus excessive? So they know that they can do it themselves, but they're not up for it. So can you give some advice around who to do the draft proofing, how much it will cost, and anything else they might need to know about, thickness of the draft proofing, or anything you've got to say about draft proofing?
Okay, yeah. So sealing out our drafts and improving the air tightness of a home, that's probably one of the most cost-effective things you can do to reduce your bills and reduce your energy consumption. Can make a massive difference. It's a bit hard to answer like how much it would cost, because the sorts of things we're talking about is putting seals on windows and doors to help stop drafts coming through. If you've got those old vents in the walls, which date back from like 50 to 100 years ago, then you can seal those up. Any other sort of leaks and cracks. So at a simple level, you're basically just paying for labour and some cheap little rubbery seal type stuff that you can purchase in a hardware store. So a handy person would be good for that sort of job. Any sort of handy person who is pretty experienced should know how to install some draft proofing seals. A really good resource is the draft proofing buyer's guide that we published in our Renew magazine a few editions ago, and I think we've got a free version of that available on the website. Maybe that's something we can check behind the scenes or later on. But there's really good information there on what products to use. The other professional that you might employ would be an energy assessor who can come in and actually find all the drafts and leaks and things. And so one way to find those is through ABSA, the Australian Building Sustainability Assessors, something like that, ABSA. Anyway, if you do a search on the internet for that, you'll find them pretty quickly. They've got lists of energy assessors that can do that sort of work for you. Otherwise, yeah, I'd just be looking for handy people, tradespeople, or do an internet search for sustainability solutions, that sort of thing.
Terrific. Thanks so much, Andrew. And a question from the same Drosera asks if it is possible to have the gas hot water system checked for someone for insulation or other issues that could make it more efficient, opposed to just an annual service.
Checking the insulation is going to be a little tricky because with a standard sort of gas hot water system, one that has a tank, it's got an internal tank which just holds the water, and then outside that you've got a thickness of insulation, and then you've got a outside cover around it. Working out how good that insulation is going to be tricky. So yeah, I haven't got a good solution for that one. Sorry. If you feel the outside of the tank with your hand and it feels really hot or warm, then that indicates that there's a problem. And but if it's only very slightly warmer than other surfaces that you touch, then I'd suggest it's probably not too much of an issue. One thing that you really can do, though, which does make a difference with hot water systems, is insulating the piping, the valves that come out. Because you can imagine if you've got a metal pipe that's connecting the hot water inside through to the outside, then you've got that's providing a path, a conduction path for the heat to come out. And so if you feel like the valves and the pipes, you often find that they are quite warm, quite hot. So again, this is like a do-it-yourself handy person job to get that foam split cylindrical insulation that you can put onto the pipes and wrap them up with tape. And there's also a product for the valve itself called the Valve Cozy. So that would be quite worthwhile looking into. Just the heat that radiates out of that valve it's a pressure relief valve that can add up to a fair bit of energy over time. Was there anything else in the question? Sorry, that I haven't got to.
No, that was that entirety of that question. Thanks, Andrew. But moving on to the next one, Kate asks, Kate says that they already have an all-electric home, including hot water, except for an instantaneous gas hydronic system. So do you have any comments about when or how to replace the instantaneous gas that powers the hydronic, maybe with a heat pump hot water heater?
We've spoken to quite a lot of householders who want to do this. Hydronic systems in general. So just for those who aren't aware, that's where you have you're heating your house through hot water pipes with hot water coming in, and sometimes you have radiators on the wall that heat up with hot water flowing through them. Other times it's heating up the slab itself, heating up the floor. And they're more common in Europe than here, hydronic systems. And in Australia, they're pretty much all gas. you can get electric heat pump units to heat up the hot water to come into the house instead of using gas. But all the feedback that we've heard is that it can be quite hard to find a company that's really enthusiastic and knowledgeable about making that conversion. Most of the companies just want to stick with what they know best, which is gas. So it's possible, people have done it, but you'll have to devote a fair bit of sort of effort to finding a company to do it. One way to find companies would be to identify the manufacturers or the suppliers of the hydronic the heat pump electric hydronic heaters, and contact them and ask for recommendations for installers that they know work with their product or trained with their product, for example. And yeah, again, we've got some lists and buyer's guides for that detail those units, the electric heat pump hydronic units.
And people would just find those on the Renew website, Andrew, renew.org.au?
Yeah. Hopefully it'll be easy to find. Yeah. I'm not 100% confident, but yeah.
Okay. The next question comes in from Faye, and she says that when they renovated the bathroom, they had a Rinnai instantaneous small system installed for water, but it takes too long to get hot water and it wastes water. So she checked with them and they said it was fine, but she still feels that it's a waste. What do you suggest?
Okay, so what's probably going on there is there's probably the water heater is probably a fair distance away from where the bathroom is. So there's a fairly long pipe which is full of cold water, because it obviously cools down over time. So then when you come and turn on the shower, then you've got hot water coming in from the water heater, but it has to push out all of that cold water through that length of pipe. So yeah, with those long pipes, you can end up with quite a lot of cold water coming out before the hot water actually reaches the shower head. There's no easy solution for that. There have been some products that I've seen in the past where they have ways of saving that cold water that comes out first, like that they have a special sort of diverter in the plumbing to drain off the cold water so it can go out to water in your garden or something. But those haven't really taken off. The other way to address it would be to move the hot water system so it's closer to the shower. But then if you've got two bathrooms, then which one do you put it close to, for example? Or install a second hot water unit. In most cases, it's not really going to be worth it. And yeah, you're probably going to have to live with a little bit of water waste, or catch it in a bucket, and especially in the drier months, or if we've got water restrictions, then that's always the sort of low-tech solution, I guess.
Yeah, nice one. Thank you. The next question is from Laura, and she's asking, what's the simplest way for consumers to calculate the rate of return on air cons? So an air con that costs $1,000 more but has a coefficient of performance of 7 versus one that, say, is $1,000 less but has a coefficient of performance of 5. How do you balance kind of cost and performance? How do you rate the return?
Yeah, that's a little tricky. It's going to depend on how much you're using your aircon for heating and cooling, and how energy efficient your house is. So if you've got a super insulated, super sealed house, then you're not going to be doing a lot of heating and cooling because you won't need to. The house will naturally stay at a mild temperature. In which case, if you're not doing much heating and cooling, then it's going to take a long time to pay off a more expensive unit through lower running costs. But I have done some estimates of this in the past, the payback time, and what I found was that yes, it's worth going for good star ratings. So just as long as you've got a 5-star unit at least, then in the small systems, that is, and then you're doing pretty well. However, it is harder to justify like going beyond that, and especially if you're going for a much more expensive brand, then yeah, it can be hard to achieve a payback in a reasonable time. Yeah, that is the sort of thing that we could analyse as part of a advice consultation. So yeah, there are ways to do it, but it's going to need a bit of spreadsheet work, basically.
Okay, thank you. The next question comes from, I'm not sure who, it's an anonymous question. And this person says that they're planning on buying an induction stovetop and wondering about the model. So do you have any thoughts on using smaller pots on larger hobs? And then there's a bit here about reduced efficiency and power use. So for example, is a 4-hob more efficient as it has a wider range of hob sizes than a 3-hob setup with larger hobs?
With induction, it doesn't matter too much because with an induction cooktop, it's just got a flat surface, but then marked out on the surface are zones which are available for heating up a pot. But if you've got a large zone and you only put a small pot on it, then it's only going to heat up the area where the pot actually is. In fact, it's actually heating the pot rather than the cooktop itself.
Okay.
So it's really not that critical if you're using a small zone on a large pot. It's not going to have a big impact on the efficiency. There may be a little bit of a penalty in the fact that when you turn on one of those zones at all, then there may be a bit of sort of standby power for having a zone running, but that's not something I'd really worry about. Yeah.
Okay.
Any induction cooktop, as far as I'm aware, the efficiency is pretty similar between them.
Okay, thank you. So, Andrew, you mentioned a couple of answers ago that it would be useful comparing your gas heating bill versus an air conditioner in heating mode. So, how do people access their bills and usage from their retailers, and how do they know their daily or weekly usage so that they can make those comparisons?
Yeah. Okay. So, in Victoria, But by the way, most of the answers that I'm giving are related to Victoria because that's where I think most of the participants will be from. But I'm aware that there are also probably participants from other states and even international. So just be aware that most of my answers are Victoria specific. So in Victoria, you get an electricity bill every 3 months normally, and a gas bill every 2 months. And when you look at the bill, normally they have like a bar chart that says, okay, this bill you use this much energy, and then the previous bill, like 3 months ago, you used that much, and the previous bill was that much, and the bill for the same time last year was that much. So that's the easy way, is just to look at your bill and compare the bar charts for this bill with the same bill last year, and because with different seasons, you're probably going to have different heating and cooling consumption. But yeah, that's a simple way, is just look at your bill and compare the bar chart. The next level of detail is on the bill. It will actually give you some statistics, some numbers. So on the electricity bill, that's how much energy you've used on average per day over this billing cycle. So that's in kilowatt hours of energy per day, and in gas it'll be megajoules. I think they give it per day, or it might just be a total over the 2 months. But either way, that's another piece of information that you can use to compare. With electricity, it's possible to get much more detailed information than with gas, because almost every household in Victoria has a smart meter these days, and that's one of the advantages of a smart meter is that it's actually measuring your consumption in half-hourly intervals. So if you go to your electricity retailer, that's a company that sent you the bill, or the distributor in your area, the company that owns the poles and wires, which is mentioned on your bill. I think for most of the Yarra area would be City Power, I think.
Mm.
Um, so, so if you go to either of those two companies, you can actually ask them for a copy of your data, your half-hourly metering data going back over a year, for example. And you can normally download that off a portal, off their website if you just register for a login and prove your identity. So if you really want detailed information, then yeah, you can get it. Yeah.
Terrific, thank you. We've got another question here about hot water, and it's from Julia, and she also happens to have an instantaneous Rinnai gas hot water service, but she's wondering, what electric system would you recommend for a two-person household, please? And is electric boosted solar hot water in the mix of best systems?
Oh yeah, solar hot water is definitely in the mix. So just to avoid confusion, I tend to refer to that as solar thermal hot water. So that's where you've got up on the roof, you've got either like a flat plate or evacuated tubes where you have like an array of tubes all sort of lined up next to each other. But in either case, they're just absorbing the heat from the sun, that direct heat, and using that heat to heat up your water directly. So some have a tank up on the roof, some have a tank down at ground level, but either way, you're just getting that heat from the sun and using it to heat up a tank full of water. The electric boosting that's mentioned there is one of the issues, or the sort of complications with the solar thermal hot water is if you have a cloudy string of weather, especially in winter, then that won't heat up your water enough. so you need a supplementary heating source, a boosting source. In Victoria, it's mostly gas that's used as the booster for a solar thermal hot water system. You can do an electric boost as well. The electric boost is a little tricky though, because normally that would be on a timer, say at the end of the day or overnight. You might have the booster come on enough to heat up the tank, but then you have to think about when you have your showers, because if you have your showers in the evening normally, then you've just used up some of the hot water out of that tank. And then the boosters come on at night and it's heated up your tank, all from electricity from the grid. And then in the morning, the tank's still hot. It's still full of hot water. So the solar thermal collector on your roof hasn't got much to do. Mm. So yeah, that's one of the complications with the booster, electric booster on a solar thermal hot water system. And that's one of the reasons why we normally say that the for a general suburban household, a heat pump hot water system is probably the sort of the go-to appliance these days. The solar thermal systems have their niches. For example, if you don't have space at ground level for a tank of hot water that comes with a heat pump, then you can put that tank up on the roof, as long as your roof's strong enough. Have it up on the roof as part of a solar thermal hot water system. And yeah, if you're off grid out in the country, then solar thermal hot water can integrate really nicely with a hot water coming off a wood burning heater, for example. But yeah, so yeah, it's possible, but they're also fairly expensive to get a good quality solar thermal hot water system. So for all those reasons, we'd see a heat pump hot water system as being most of the as a sort of the default option for most households.
So while we're talking about heat pump hot water systems, there's a couple of questions that have come in about those. Okay. So again, for an average household of two, can you give some tips about what size or kind of system to look for? Are there any good brands or not? You mentioned earlier on that some are noisy perhaps and some not. How do you find the right one for you?
Yeah, we normally don't like to say, go with this brand, and because yeah, we stay independent at Renew for giving advice. But the sort of things to look for in the slides, I mentioned one which is what's the refrigerant gas that it uses. So the refrigerant gas is what's used within the heat pump to circulate from the inside the machinery, basically, to do that heat pump cycle. And the best models use carbon dioxide as the refrigerant gas. It sounds like that would be a bad option because we all know that carbon dioxide's not doing good things to our atmosphere, but actually, a carbon dioxide it's got advantages for quite a few reasons. One is that if it was to leak out of the pipes, then okay, it's not great for the atmosphere, but it's only a small volume. And if you compare that against the other refrigerant gases, most of them are actually quite nasty for the environment. Their impact once they get up in the atmosphere is they create reactions, chemical reactions, which end up much worse for global warming than what carbon dioxide is. So there's one advantage of using CO2, carbon dioxide, as the gas in the system. The other advantage is that it gives higher efficiency. The CO2 units they work at a high pressure, so they tend to be a bit more expensive, but yeah, they're good quality and highly efficient. At the moment, there's only 2 units on the market in Australia at the moment that use CO2 as a refrigerant gas. But yeah, since there's only 2, I might as well mention them. So one's the Sanden. That's SANDEN. That's been in the market for probably a decade now, I guess. Quite a few years anyway. And all the indications we've had is that it's good quality, reliable, quiet. I've got one myself. The other one in the market is newer. It's called Reclaim Energy. It's got similar specs to the Sanden, and it's also got some clever features for how it can interact with, if you've got solar panels on the roof, to make the best use of the solar generation as it's being generated. So you're using more of your own solar and less electricity from the grid to heat up the water. So that one's worth having a look at too. And it's also got a few different choices for what sort of tank you have.
How would you pick the right size, Andrew?
Sizing. I think the rule of thumb would be based on the number of people in the household. I think they normally say allow tank volume of around 50 litres per person plus 20 litres. I think that's the sort of traditional rule of thumb. But the thing to keep in mind is that's assuming that people use a certain amount of hot water per person, and that can vary hugely. So just think about the variables involved. Like, so some people have 3-minute showers and some people have, 20-minute showers. so there's a factor of 6 times already, right?
Yeah.
Then you've got the flow rate coming out of the shower head. So some showers are made to be really efficient, so that even with a fairly low litres per minute of water coming out of them, they still feel pretty good as a shower. But others just have, huge amounts of water coming out. I don't know if anyone saw the Fight for Planet A with Craig Rucastle on ABC. If you haven't, you should. If you're attending a webinar like this, you'd probably really like that series on the ABC. But yeah, he had some quite eye-opening stats on a house with a shower head.
Yeah, that's on iView at the moment, I think.
On iView on ABC. Yeah, that's definitely a good one to watch. So that's 2 variables, like how long is your shower and how how fast is the water coming out, and then the other one is how many showers does your household have per day. So, like if you're playing lots of sports and getting sweaty, then you might be having multiple showers a day. So really per person, that is. So the quick answer would be, for if it's only two people, then you might go with one of the sort of smaller tank options. But yeah, just think about how much hot water you're actually going to use, and also if you're going to have times when you have guests coming and taking extra showers and things. So
Sure.
yeah.
Now, one last question for the minute about heat pumps. Timothy asks, besides available space, what are the pros and cons of a split or integrated heat pump hot water system?
Space is probably the big one. That's the main sort of advantage of an integrated hot water tank, where you've got integrated heat pump hot water system, where you've got the water tank and then a sort of small fan unit, mechanical unit up on top of it. The advantage of the split system is that they tend to be a bit more efficient, and they can be quieter as well. Because when you've got a larger fan, then for the same flow of air, it doesn't need to spin as fast. So they do tend to be quieter. So yeah, in general, I would sort of lean towards the split systems if you have a choice, but they're also good integrated units if your space is fairly tight. Oh yeah, just on that though, you do normally have a reasonable amount of flexibility in where you can locate the two units in the split system, the tank and the fan unit. Like I think with most brands, you've got maybe 5 or 6 meters that you can place the distance in between the tank and the fan unit. So that may give you some creative solutions for putting it mounted on a bracket on a wall or around a corner, or if you got a fair bit of space under the house, then you might even be able to put it in the under house space, and just as long as you've got good ventilation and access to airflow under there. So yeah, hopefully that answers that one.
Yeah, nice one. Thanks, Andrew. 101 questions about heat pumps, yeah? There's a question here from Marcus, which has been here for a little while, but I think Damien might have answered this. And it's about, Marcus says that he's interested in going solar and has a very old original Victorian terrace roof structure, and he's not sure that it would be able to withstand the extra weight. Installers have shown no interest at all in looking at the roof. What would you do? What would you suggest to him in terms of getting an assessment on the roof?
Okay. Yeah, with solar installers, the market has sort of moved a bit in the last 5 to 10 years. Traditionally, a solar installer would come out on site and have a look at your roof, have a look at your electrical switchboard, look at any shading from trees and buildings and things, and do all of that stuff before they actually gave you a quote. But nowadays things have moved on, and most of the solar retailers, they'll do a quote without anybody coming on site. That enables them to keep their costs down, because it is actually reasonably expensive to do site visits, and they probably have to do a few quotes for every job that they actually get. So it's understandable, but it does make it tricky for people in your sort of situation. If you keep looking around, you will be able to find solar installers that will come out on site and do a quote. Maybe not right at the moment with the stage 4 restrictions, as solar installations are pretty much gone on hold for the moment. But yeah, once that eases up, then yeah, you should be able to find a solar installer, especially some of the ones that have been around for a very long time with a sort of more of a premium reputation in the market. They're the ones that are more likely to provide that level of service, I guess. And if they're experienced, they'll have they'll be able to have a look at the underside of your roof, like inside your roof space or whatever, and they'll be able to give you a pretty good assessment of whether the roof looks strong enough to support the weight of the solar panels.
Terrific.
The panels themselves don't weigh very much. Like each normal panel will probably weigh about 20 kilograms, and that's spread over like more than 1.5 meters. So the weight of solar panels is less of an issue for a roof than having a tradie with all his tools actually walking on the roof. That point load is more of an issue for roofs than what solar panels would be. So yeah, normally it's not an issue. That's assuming that the panels are flat on the roof. If you got more like a horizontal roof and you got the panels on a tilt, then the issue is the wind loading, because it can act like a sail and try and actually lift off the roof when you have a really strong wind. So that's where you want to be a little more careful, I guess. But if it's just going to be flat on the roof, then you're unlikely to have a problem.
Nice one, thank you. Lots to think about, isn't there?
Yeah.
The next question comes from Kate, and she says that their electricity distributor restricts their solar PV system size to 5 kilowatts. So how do they know what size solar system they need to power their home? And secondly, is there any way around those restrictions?
Okay, so yes, the distributors. So that's the company that owns the poles and wires in your area, and you don't have a choice about that. That's what you're stuck with. They've got a monopoly in your area. And if you're getting a grid-connected solar system installed, then they do have to approve it, and because you're sort of messing with their grid, basically, which is a shared asset for all your neighbours and everything. So yeah, they do tend to put restrictions on. Sometimes they put restrictions on the size of the solar system, like say like a standard solar system these days, it would have a 5 kilowatt inverter. That's the rated power level of the inverter that puts out the 240 volt AC electricity. So your distributor, let's say for example, this is City Power. They might say yes, you can have an inverter up to 5 kilowatts, or they might say no, you can only have one up to 3 kilowatts, because the poles and wires in your street aren't really up to handling it, or there's too many other people with solar in your area. So that's one sort of restriction they might put on, but more common is not so much on the power of the inverter, the size of the inverter, but more on how much power you're allowed to export out to the grid at any point in time. So they might say, okay, you can have a 5 kilowatt inverter, you can have an 8 kilowatt inverter, whatever, but just as long as you're not exporting out more than 5 kilowatts of power at any time. So that's more likely, and we're seeing a lot of that. In some parts of the grid, they're being tougher, and they're saying, oh, actually, you can only have 3 kilowatts. And we're seeing places out in the country, especially where they're connected to long stringy lines, where the distributor's saying, okay, you can put a solar system, but you're not allowed to ever export anything. Zero export, which is a real issue, because for most households, if you're putting on a sort of average size system, for, say a 5 kilowatt inverter, then most of your generation would actually be exported out to the grid. It'd only be maybe 20 to 50% of your generation that you're actually using immediately on site through your appliances. So a zero export limit is really going to affect your economics and your environmental benefits. If it's a 3 kilowatt export limit or 5 kilowatt, then that's going to be okay. And because most of the time, even if you've got say a 6 kilowatt solar system, that's what it's rated at laboratory sort of perfect solar test conditions. Most of the time, it's not going to be generating anywhere up to that 6 kilowatt level. It'll be more around the sort of 2, 3, 4 kilowatt level. And then your house is going to be using some of that anyway. So yeah, if you're getting slapped with a 3 kilowatt export limit, that's probably not too bad. Now, what size system do you need to power your house? That's an interesting one. Traditionally, when we're advising people, we would take a fairly careful approach and say, well, let's look carefully at how much electricity you're consuming per day, and only recommend a system that's large enough to sort of cover that. But that was when solar panels were really expensive, and they're so cheap now that that sort of approach doesn't really make sense anymore. So in a way, it's a lot simpler. It's pretty much, well, you might as well go for a 5 kilowatt, 6 kilowatt solar system. That's the size that most installers and retailers are trying to sell. That's their sort of standard size. If you go smaller than that, then the pricing tends to get a bit less value for money. And if you go bigger than that, then you can often get more value for money, because while they're up on the roof, it's relatively cheap for them to put extra panels on as part of the same job. So yeah, I wouldn't stress too much about trying to identify like a perfect level. I mean, that's something we can do as part of an advice consult as well, if you want, where we can really get into it. But if you're a typical sort of household, then yeah, a typical size solar system is normally about right.
Nice one, thank you. Laura asks about, and is there any potential to get a second-hand solar hot water system? So are there any cheap and old ones around that could still work? And if so, could it work if you had 2 or 3 solar thermal hot water systems put together to heat the one tank to compensate for cloudy, wintry days? Would that work?
Yes, it could work. There's a few hurdles and issues though. The first hurdle would be finding an installer that's willing to work with an old system, because they're probably going to be a bit wary of saying, well, what if I put this system on the roof and then they have problems with it, and then I'll have a nightmare of trying to diagnose what's wrong with this system where I don't know what its provenance was and what's happened to it, and how old it is. And yeah, so I think you might struggle to find an installer to actually work with you on that. It seems that a lot of the expertise has sort of left the market a bit with the solar thermal hot water. If you went back, say, 10, 20 years ago, there were probably more companies around that had really experienced, skilled experts with the solar hot water who might have been more willing to work with some non-standard kind of systems. But I think these days, the solar thermal hot water, it's less popular now than what it used to be, with the exception of new homes that go up. In Victoria, we've got a crazy sort of requirement for a new home to meet the 6-star Energy Star standard. They have to have the right amount of insulation and everything, but they also have to have either a rainwater tank or a solar thermal hot water system. And there are some ways around it. It's not purely black and white, but that's what a lot of new homes going up in the new suburbs, the new housing developments, especially if they don't have space for a rainwater tank, then you'll just see 2 panels on the roof, and that's probably a fairly cheap and nasty solar thermal hot water system. So there is that market, but the market for really good quality ones is not what it used to be. So sorry, I've gone on a bit of a tangent there, but it may be hard to find someone to do what you want. And apart from that, if you're going to oversize the collectors, you're talking about having like 3 sets of solar thermal collectors connected up to one tank, you might run into problems in summer with overheating. So, and they can actually boil the water in the tank. So some people have gone to extremes of putting shade cloth or some sort of blinds over them that they can vary the amount of shade that's going over the panels, that sort of thing. But yeah, that's something to be aware of, and because if the tank boils, then you can have hot water coming out and running down the roof, and then we've heard of cases where it's even over time it's actually damaged the colour bond roof. So the other alternative is to tilt it up really at a fairly steep tilt, so that in summer when the sun's sort of overhead, then that it's not exposed to as much sunlight, so it naturally reduces the overheating. And in winter when the sun's low in the sky, then it works really well. But yeah, high tilts can be hard to achieve as well, and a bit tricky to extra sort of workmanship and materials to achieve. So everything that you say is possible, but it's a bit of a involved project. And for most people, they'd probably be better off just using that roof space for standard solar electric panels, and then having a heat pump or something else down at ground level.
Okay, thank you. Now back to solar PV for a second. Max says that he has an existing 2.5 kilowatt solar system and is wondering about the best way to upgrade to a 5 kilowatt system. So is it simply adding another inverter and adding more panels, or is it really about getting a new inverter and a whole new set of panels?
Either way can work. Yeah, I'd be probably getting a quote for both options, and then you can weigh them up. So you might find that actually the quote to put on a whole new system, okay, it's a bit more than the cost for a small system, additional system, but it's not that much more. So then you might think, well, I'm ending up with newer technology, more efficient panels. Everything's all one system, all working together. They're all new panels rather than 5 or 10-year-old panels on the roof. So if that price difference isn't too big, then you might be advised to just get a whole new system.
Okay.
But yeah, get a couple of quotes for both different options. The one thing to watch out for is if you've installed 10 years or 12 years ago, then you might be on the premium feed-in tariff in Victoria. And if that's the case, then that's really worth holding on to, that special deal, that special contract. And there's still 4 more years to run on that. So if you are on that contract, then installing extra panels will expose you to being booted off the contract. So you might be better advised to just hold on for another 4 years and then look at expanding.
So what happens in 4 years, Andrew?
That's when the premium feed-in tariff deal expires. So people who installed solar panels like in between like 10 years ago and earlier, most of them are on that deal with the premium feed-in tariff. So they're earning like 60 or 70 cents per kilowatt hour for energy that they export out to the grid, rather than around 10 cents, which is what it is now. Which is counterbalanced by the fact that when they install, their solar panels are so much more expensive. So it sort of swings and roundabouts. But yeah, if you are getting that good feed-in tariff, then it's worth holding on to. Yeah.
Okay, thank you. Now, off on a completely different subject now. Jean asks, how advisable is it to fit double glazing to existing single sash windows? How advisable and perhaps how easy is it, or not?
Yeah. And so we're talking about retrofitting or modifying the existing windows to put double glazing on. Well, I guess it's a matter, when we're talking about advisable, you can think about like a list of priorities, I guess. Probably higher priority than that would be draft ceiling insulation, external shading on your windows if you've got summer sun coming in through the windows. You could maybe look at internal window coverings, like either heavy curtains with pelmets or honeycomb blinds with a good insulation value. So those are all things that you might consider before you go to double glazing, I guess. But yeah, having said that, if you've done those other things, then double glazing is definitely worth looking at. It can make a fairly big difference. A single pane of glass has very little insulation value. It's it'll stop the wind blowing through, but the heat can soak through that glass pretty quickly. Like you can imagine, if you have a drinking glass full of hot water, then there's not a lot of insulation there. The outside of the glass still gets pretty hot pretty fast. So there's a couple of options for how you could do that. One is to add on, so you've got your existing pane of glass, and it'll have like a timber frame around it. To add on like another sheet that's normally like plastic, like acrylic plastic, I think is normally used. So there are products out there that companies can make up these sheets of plastic with the right sort of trim around it that fit into your existing timber window frame, and they look pretty good, and they provide that air gap in between the two panes, which gives some insulation value. The other option would be, there's also companies that can take out your existing single pane of glass, and where the pane of glass went in like a groove in the timber, that they enlarge that groove, and then they put in a double glazed unit. So that's probably a slightly more proper way to do it, I guess. Slightly more sort of comprehensive way to get a real double glazed unit in your window. But that's going to be more expensive. There's more work involved with, modifying the timber work to install that new double glazed unit.
Okay.
So yeah, look, for an average sort of household, it wouldn't be the top priority, but yeah, definitely worth looking at. Or for some households, you might think, well, how much life have the windows got in them? If they're starting to go, if they're on their way out, and you're probably going to need to replace them in, say, 5 years, then you might just hang on with what you've got, and just wait till you need to replace the windows, and then when you do replace them, go for double glazing. That's a more cost-effective way to do it, rather than the labour of sort of upgrading an existing window, I guess.
Nice one, thank you. Now the next question was back to heating again, and it's from Maria. And Maria asks about the best options for portable electric heaters for just heating one room for a short period, such as having a guest in a spare room or using it as a study only now and then.
Yep. So that's portable. You can get portable air conditioners, but if you do that, then look for one that has like a duct that you can put into a window to exchange air with outside. But yeah, they're not necessarily that cheap.
So is that a heater as well, Andrew?
Yeah,
a portable heating system. Okay.
Reverse cycle air conditioners that can do heating as well as cooling.
Yeah, right. Yeah. Okay.
But the more inexpensive option, which I think what the question was, inexpensive portable heating, would be something like a oil column heater or like a little bar radiator, any of the fan, electric fan heater. So any of those sort of electric heaters that are not an air conditioner, their efficiency is going to be pretty much 1 for 1. So 1 unit of electrical energy is going to give you 1 unit of heat coming out. So they're all going to be, on that measure, they're all going to be basically as good as each other. The proviso would be, if you've got a very leaky space that you want to heat, or if it's got really high ceilings, for example, then heating the air is going to be difficult, because the air's going to be either moving away or leaking out. So in a situation like that, what you want is radiant heat. So either a bar radiator or one of those panel heaters that you can put on the wall or stand up somewhere most of the heat comes out as a radiant heat. So if you stand in front of it, it's like standing in front of like a fireplace or something. You can feel that heat on your skin that's facing the heater.
Yeah.
But yeah, basically any option that you favour that's relatively cheap and portable, they're all going to be pretty much as efficient as each other.
Great, thank you. Now, the next couple of questions are about insulation. One is about ceiling insulation and how you know about the thickness of the insulation and you know, what do you need, how much do you need, what thickness do you need, essentially some advice about that. The second question is around insulation under a timber floor and what is the best type there, and would that be the polystyrene that fits between the joists, or perhaps it's something else? So ceiling and then floor insulation.
Okay, so assuming Victoria, the standard sort of insulation that's going in for a minimum 6-star rated house for like a new build is rated at an insulation value, an R value of 5 or maybe 6. So what that normally looks like is an insulation bat. You know those big, thick, fluffy insulation bats. So you're probably looking at something like maybe 20 centimetres at least thickness, probably. So they normally go in between the timbers over the roof. They sit in between those just on top of your plasterboard for your roof. So that's the sort of thing I would be looking to achieve, is a nice thick insulation bat that's in good condition, hasn't been sort of squashed too hard or damaged by like possums and rodents. So yeah, you can either get up in the roof space, or if you're not confident with that, then you can pay a handy person or a tradie to go up and have a look for you. The other thing you're looking for is coverage over the whole ceiling, and because often we see cases where the tradies haven't completed the job. Maybe they were doing it on a day when the temperature up in the roof space was like 50 degrees or something. So it's understandable they wouldn't want to spend too long in there. It can actually be quite dangerous. But still, we see corners that have been cut where in some of the hardest spots to get the insulation in, like up at the corners where you've got the ceiling and then the roof that comes down. So it's actually, you don't have a lot of head space or crawl space to move around. So where it gets tricky, often they've cut corners and the insulation is not even there. Or maybe the insulation was there, but then subsequent to that, they've had electricians or some sort of other tradie up in the roof, and in order to do their work, they've moved the insulation out of the way, but they almost never put it back again. So, that's what you want to achieve, is like a nice even coverage, continuous coverage of nice thick sort of insulation. So that hopefully covers the ceiling. On the underfloor, there's a few options around. And there's no sort of obvious, clear kind of best option. The polystyrene is one where often they're like a polystyrene board with a bit of expansion sort of joints in them, so they can be pressed out in between the timbers under your floor. That's a pretty good option. Another option is, again, insulation bats. Polyester tends to be the material that's used under the floor. And there's a few companies in Melbourne that will install polyester bats. They have like big continuous rolls of them that they roll out and they squash them up in between the timbers, and then they have these electric staple guns to like staple through the edges of the insulation into the timber. So if I was looking for a default option, I'd probably go for that one, with the polyester insulation, because it's quite flexible. So especially if you've got like an older house where the timbers aren't straight, or you've had renovations done and they're sort of, you know, all over the place and different widths and stuff, then you've got a bit more flexibility, I guess, with the polyester rather than the styrofoam.
Thank you. Now, one last question back on the ceiling induction for a minute. What do you do about all the electrics in your roof after you've had the insulation put in? Do you need to have an electrician come and double check that it's all as it should be?
Right. Yep. So the concern there would be if you've got an electric cable which previously was just in free space, and now you've put this big thick insulation on top of it, and there may be insulation underneath it as well from a previous job perhaps, then electrical cables can get warm if they've got a high current going through it. If it's supplying an appliance that's running at a high power level, then yeah, the cable might get warm. Normally no issue, but if you've encased it in this insulation, then the heat's got nowhere to go, or not very fast anyway. So the cable could overheat and eventually melt the insulation, and then you have a short, and your isolations switch trips in your switchboard, and something's gone out, and you have to get an electrician back to work out what's happened and fix it. So how much of a worry is it? It depends a bit on your existing wiring. So if you've got wires that are sort of operating at the limit of their capacity already, then that's where you might have an issue. Especially if you've got a house with like really old wiring, maybe something different than the normal sort of white electrical cables that we have at the moment, then that's when you would have more concern. But I guess the answer would be yes. If you're going to put insulation in, then it is a good idea to have an electrician come and have a look first. And what they might do is say, okay, well, we've got these cables, and you've got these cables coming down to a circuit breaker with a certain rating on it. I'll swap out that circuit breaker with another one with a lower rating, just to make sure that even if you've got your kettle and your toaster and your hairdryer and everything all running off that power board on that socket, then what's going to happen is the circuit breaker will just trip first to protect that cable from having too much current flowing through it in between all the insulation.
And just to double check, you'd get the electrician in after or before the insulation's put in?
Before, yeah. Okay. That would be best, because if the insulation's gone in and it's hiding the cables, then it might be harder for the electrician to work out what they have to do.
Great, thank you. Now we've got a few more questions here, and I'm mindful that we probably only have about 5 more minutes, so we'll try and power through a few. So Debbie says she has a Sandon heat pump, hot water system, and she never uses anywhere near all the water in the tank because it's only her living in the house now. Could she have a hydronic heating panel installed in her house and use the same tank to heat that?
Sandon have actually changed their warranties. So previously there were some people using those Sandon hot water units for hydronic, but since then I'm pretty sure Sandon have come out and said that that they won't honour the warranty if it's being used for that purpose. So I'd be a little careful. Yeah, if we're powering through, I might leave it at that.
Yep, no, cool. The next question is from Tammy, and she said a few years ago, induction cooktops had a reputation of not being as responsive as cooking with gas. They're a bit slow to heat up and a bit slow to cool down. So are the newer induction stoves now good? Are there some more responsive than others?
I think there might be a little bit of confusion about what an induction cooktop actually is,
Okay.
because there are some sort of flat cooktops that look like induction, but they're actually not. They're normally called ceramic or something like that. But so those cooktops, they're still just heating up like the old-fashioned electric one, where it's a resistive element that's heating up the cooktop itself. And yes, those ones can be slow to heat up and cool down. Yeah, but a
Okay.
real induction cooktop actually, they're very fast to heat up. It seems like the manufacturers have gone on a bit of an arms race between each other to see which ones can have the higher power level. So yeah, there any normal induction cooktop, it can boil faster than what a gas cooktop can, and they're also very responsive, like to change the power level as well. One thing to look out for, though, is the responsiveness of the buttons themselves, because, yeah, we've got an induction cooktop here, and it, we've never been quite happy. It was a fairly cheap brand. We've never been quite happy with, like, to change the power level, you have to do several deliberate presses to go, like, from power 1 to power 5. So, yeah, that's why it's good to like test how they operate before you get it, I guess.
Yeah, no, good advice. Thank you. The next question is from Kate, and she, gosh, you could answer it. I have a big answer for this question, but what would you recommend to do for a house with an old school ducted heating system with floor vents powered by gas?
Okay, ideally, standard vanilla sort of option would be when that heater needs replacing, or it's getting really old and inefficient, then get rid of it and go with split system reverse cycle air conditioners inside the house. You've probably got one already for the living room. You may already have one or two in bedrooms, so you may only need to add one or two more, and yeah, you'll have a more efficient, cheapest, more environmentally friendly solution that also has the bonus of being able to cool you in a summer heat wave.
Nice one.
So,
Thank
yeah,
you.
that's the sort of default answer, but every
Yep,
situation has their
of course.
differences. Yeah.
And I guess, on that, there would again be more information on the Renew website. Yeah?
Yeah.
Yeah. The next question is back to the topic of insulation. And it's a very specific question about what would you do for the ceiling of a carport where there is a room above it?
Ooh. Okay. So we're talking about insulation between the carport and the room, I guess.
I guess so.
Well, it depends what sort of structure the carport is, but if it's got either metal or timber sort of support beams, then try and get some insulation in between those, and if necessary, put a like a ceiling on the bottom of those beams, like a ceiling for the carport to hold the insulation in place, and help prevent the drafts. So it's a bit of a generic sort of answer, I guess, but that's probably all we can do at this stage.
Yeah. Thank you. And the very last question for tonight, Andrew, and is back to the topic of solar panels. And Laura has mentioned that she has seen a number of cheap solar panels. I'm not sure if they're secondhand, but solar panels available very cheaply on Gumtree. So any advice regarding those, and how would someone know if they're any good, if they're in working condition or not? What should she check or look out for?
Okay, well, if it's for a proper grid-connected solar system on the roof of your house, then just ignore Gumtree, because you're to meet the current standards, the solar panels that are being installed on your roof have to have been tested according to specific fire safety tests and things. And the ones on Gumtree will be old ones that have come off someone else's roof, and they even though they may be perfectly safe, they almost certainly won't have been through those tests. So technically, they aren't allowed to go on your roof.
Okay.
Yeah, you're much better off just going with a good quality, a good solar installer. and they'll get the solar panels as part of their job, and it's the solar panels which actually qualify for the rebate, the STC rebate. So the panels themselves aren't a very expensive part of getting a solar system installed. So yeah, it's much better to get new panels. Yeah.
Terrific.
If you just want a couple of panels for camping or for running a water pump at the bottom of a paddock or something, then the Gumtree ones are fine. But a proper system on a house roof, then yeah, go with the proper installer.
Terrific. Thanks very much, Andrew. So that brings us to the end of the questions, and we've come to the end of our time. We've quickly got to 8:15. So I'd like to say thank you so much to you, especially Andrew, for the many questions you've answered tonight, and the technical expertise across a whole bunch of different topics that you've provided all of us with. So thank you so much. And thanks to Damien for being our Zoom controller in the background and keeping everything ticking along. Thanks so much to my colleague Kelly, who's kept an eye on chat and been passing through the questions to be asked. So thank you too. And especially a thank you to everyone who came along tonight. And we really hope that you've had an opportunity to have those questions that mean something to you and your circumstances answered. Don't forget, if you have more questions or things that you'd like to follow up on, you can find more information, especially on the Renew website, which is renew.org.au. But you can also find information about going solar, especially in the city of Yarra, on the Yarra Energy Foundation website, which is yef.org.au. And of course, you can find information about going solar, buying 100% renewable energy, and transitioning from gas to all electric on our council website as well, which is yarracity.vic.gov.au. So lots of resources out there to help you in your transitioning from gas or fossil fuel powered homes to renewable energy powered homes. But again, thanks Andrew, thanks Damien, thanks Kel, and thank you everybody for coming along tonight. Thank you for spending your Thursday night with us. Good night.
Thank you, Sam.
Good night everybody.
Bye.
Bye.